Assalamu alaikum students. This is Noman Ahmad, your physics teacher. So in pre-coaching classes we will start from unit number 4. So unit number 4 is turning effect of force. In this unit we will start from the topic torque or moment of force. This topic is on page number 90. So after watching this video, you should know about the torque or moment of force. You should know that how this torque plays its part in opening and closing of door, and what are the factors which are affecting the torque or turning effect. Before starting this lecture, students should know about like and unlike forces, how we can add forces by head to tail rule, how can we find out the resultant force, and in the topic resolution of vectors, how we can resolve the vector into its component. Likewise, how we can split up vectors, and how we can determine a force from its perpendicular component. So coming towards the topic torque or moment of force. First of all, I will start from force. That what is force? Students, you know, a force is that agent which causes an object to move, or it also causes to stop the moving object. Okay, similarly the force also produces rotation in an object. Okay, it causes an object to move around its axis. For example, in the given figure, this swing will be rotated if you apply force on right hand side. Then this force will cause this swing to rotate in a clockwise direction. Okay, likewise, if you apply a force in left hand side, then this force will cause this swing to move in anti-clockwise direction. Okay, the pivot point is also called fulcrum. This swing is free to move around this pivot point. The force can cause an object to rotate, and the turning effect of the force is called moment. When we apply force on an object, then this force causes that object to move around a fixed point. Okay, and this movement, this turning effect, this rotational effect is called the moment. For example, in the figure you can clearly see a spanner. Okay, and this is a nut. If you put this spanner on this nut and we apply force here, then what will happen? if you apply force in this direction, then this nut will rotate around clockwise. Okay, it will start turning, it will tighten. ये टाइट होगा ये नट, ठीक है. Now the distance from this pivot point to the line of action of force, this distance is called the moment arm of force. Okay, the turning effect, this turning effect will be proportional to this moment arm and this force. If we increase this moment arm, this distance, then the turning effect will be larger. Okay, and similarly, if we apply more force perpendicularly, then the turning effect produced will be larger. We can derive the formula of torque. Okay, its formula is simply the force multiplied by the moment arm or the distance. So this is its mathematical form. Tau is equal to F multiplied by D. Okay, its unit is Newton meter, the unit of force is Newton, and the distance, the unit of distance is meter. Okay, so the torque unit is Newton meter. Again, one more important point. For example, in the second figure, you can see clearly that we can open or close the door easily by applying force. Then this force which we, if we apply on this handle, this force will actually produce the turning effect around this, around these hinges in, okay, around these hinges which is in, ठीक है students. So if we apply force, then this force will cause the rotational effect, the turning effect, torque, and due to this torque, this door will be able to move around it, the around this axis. Okay, this vertical axis. And the distance from the door handle to its axis of rotation is D, is moment arm. Okay, the more, so force multiplied by D will give us torque, and as a result of this torque, this door will be able to rotate. We will discuss this phenomena of torque a little bit more in this slide. For example, in here is a nut and a spanner is placed in that nut. Okay, if we apply force, then we can easily move that nut. Okay, either clockwise or anti-clockwise, it depends on the direction of the force. The distance from pivot point to the line of action of force, this will be the moment arm D. Okay, so D multiplied by F will produce the turning effect. Okay, the torque. The more the force and this displacement, the more the torque will be produced. And one important point, to tighten or loosen the nut, you apply a force to best advantage at 90 degree to a spanner itself. What does this point mean? This point means that you have that when you apply force perpendicularly, then the turning effect will be maximum. ओके, अगर आपको इस नट को इजीली रोटेट करना है तब आपने जो फोर्स अप्लाई करना है वो मोमेंट आर्म के परपेंडिकुलर अप्लाई करना है, ठीक है। मतलब कि 90 डिग्री के एंगल पे जब हम अप्लाई करेंगे फोर्स तो हम इजीली इस नट को बाय मीन्स ऑफ दिस स्पैनर इजीली हम ओपन या क्लोज कर सकते हैं, ठीक है। मीन्स टाइट या अनटाइट कर सकते हैं। सिमिलरली अगर आपको एक डोर या घर का गेट खोलना है तो आपने फोर्स हैंडल के बिल्कुल परपेंडिकुलर अप्लाई करना होगा, ठीक है, तब आप इजीली उस गेट को मूव कर सकते हैं। यहाँ पे आप फिगर में क्लियरली देख सकते हैं कि अगेन एक स्पैनर है जो कि एक नट पे लगा हुआ है, ठीक है। इन सिचुएशन ए there is a long spanner, okay, and when we apply the force perpendicularly, the torque produced will be greater, okay. Similarly, in situation B, the length of the spanner is long, okay, this moment arm D is long, but in here the force is not perpendicularly, okay. The force is, let's suppose this force is at 45 angle. So what will happen? The torque produced will be less, the turning effect will be less, okay, because we haven't applied force perpendicularly. And in situation C, the torque will be less because you can see clearly the length of this spanner is very short, okay, compared to situation A or B. So we reduce the moment arm D here. So even if we apply the force perpendicular, the torque produced will be less because we reduced the D, the moment arm, okay. जब परपेंडिकुलर डिस्टेंस T रिड्यूस हो जाएगा तब हमारे पास टर्निंग इफेक्ट जो है वो कम प्रोड्यूस होगा। और ये बात हम अकॉर्डिंग टू द टॉर्क फार्मूला कर रहे हैं, टाई इज इक्वल टू आर डी मल्टीप्लाई बाय एफ, ऑलराइट। The product of force multiplied by moment arm gives us the turning effect, the torque. So जब हम एक भी इनमें कम करते हैं, एक भी फैक्टर आइदर फोर्स और मोमेंट आर्म, तब हमारे पास टर्निंग इफेक्ट जो है वो कम प्रोड्यूस होगा। These are some practical examples of turning effect. For example, in figure number 1, a person pushing a swing will make the swing to rotate about its pivot point. We discussed this example earlier, okay. Similarly, we discussed the second figure also, that a worker applies a force to a spanner, then what will happen? It will cause a nut to rotate, okay, in the direction of the force. Similarly, we can open the bottle's cork by applying torque, and similarly we can move the steering wheel of a car by applying torque, okay, either clockwise or anti-clockwise. Next is the example related to this topic, which is example number 4.3. A mechanic tightens the nut of a bicycle using a 15 centimeter long spanner by exerting a force of 200 न्यूटन। एक मैकेनिक है जो कि एक बाइसिकल के नेट को जो है वो टाइट कर रहा है, वो यूज़ कर रहा है 15 सेंटीमीटर लॉन्ग स्पैनर, ठीक है। स्पैनर की लेंथ कितनी है? 15 सेंटीमीटर है। मीन्स के जो परपेंडिकुलर डिस्टेंस है वो हमारे पास 15 सेंटीमीटर है और फोर्स हमारे पास 200 न्यूटन है। फाइंड द टॉर्क दैट हैज़ टाइटन्ड इट। हमने टॉर्क फाइंड आउट करना है कि कितना टॉर्क प्रोड्यूस हुआ जिसकी वजह से वो नट जो है वो टाइट हो गया है, ओके। फोर्स 200 न्यूटन गिवन है, लेंथ 15 सेंटीमीटर है, जिसे हमने फर्स्ट ऑफ ऑल मीटर्स में कन्वर्ट कर देना है। ओके, सो 0.15 मीटर्स आ जाएगा। टार्क का फार्मूला है टाई इज इक्वल टू एफ मल्टीप्लाई बाय डी। डिस्टेंस यहाँ पे एल है, सो फार्मूले में टाई इज इक्वल टू एफ एल लिख लें। एफ भी गिवन है, एल भी गिवन है, जस्ट पुट इन वैल्यूज़ इन द फार्मूला एंड टॉर्क की वैल्यू हमारे पास आ जाएगी। टॉर्क की वैल्यू 30 न्यूटन मीटर हमारे पास आ जाएगी। ओके, सो अ टॉर्क ऑफ 30 न्यूटन मीटर इज़ यूज टू टाइटन द नट। If you have any question related to this topic, you can ask. You can contact me on WhatsApp. Thank you.